Due to time constraints, this is the second part of the Week 1 videos. We'll continue now with examples 3 and 4 from Lesson 1-1. Before we get started, you'll want to view this diagram to avoid a common mistake or misconception. Any graph that is above, or part of the graph that is above the x-axis, we refer to as positive. It's having positive output values. Also, any graph that's below the x-axis is referred to as the negative region, or having negative y values. When someone refers to increasing of a function, that is where the function is having a positive slope, not to be confused with the positive y values. So that's why we refer to a positive slope as increasing. Therefore, a negative slope function, as the orange indicates, or part of the function, is decreasing. Let's use those ideas to answer some of the next examples. For example 3, they want to know when is x squared minus 9 positive and when is it negative. You can graph it on any of your tools, and here I have an example of it. So positive, again, is when the function is in the positive region, so above the x-axis here. And while I can't write on it, you can see it's just above the x-axis. It appears to be the cutoff here is 3 back, so negative 3 and positive 3. We're going to use just our interval notation. So when we're looking for the positive part of this function, we would say from negative infinity to negative 3 and 3 to infinity. Sometimes it's actually, these two sets can be held together by what we call the union symbol, so you may see a U in there as well. Notice how I used x values. So this is referring to the x values of the function for when the y values are positive. That's why I used negative 3 and positive 3 as my cutoffs. Now, when is the function itself negative? That'd be below the x-axis. That's going to be all down here, so in between that negative 3 and positive 3 value. We would say soft bracket negative 3 to the positive 3 value with a soft bracket. This common error down here, especially if we didn't get to talk to you in class, has to do with the fact that some students will indicate that 3 or negative 3 have positive and negative values. And that does mention this part of the question where the intervals meet. We don't say that positive or negative 3 are either positive y values or negative y values. They are actually 0 there. So we do not use hard brackets at all when we're talking about the end or the beginning of the intervals. Let's take a look at another one. For what values is 2x plus 10 positive? Now we have a linear function. Again, we're going to look at the x values for when the y values are above the axis. So here is negative 5. The graph goes above the x-axis after. So we will say it is positive from negative 5x value to infinity, because as we travel farther, every x value here will give us a positive y value. When is the function negative? That's when the graph is below the x-axis. That'd be from negative infinity to negative 5. Notice that the infinity symbols always would have a parenthesis. And because at negative 5 it's neither positive or negative, we don't include those values with a hard bracket, because at that negative 5, the function is neither positive nor negative. Example 4. We have the graph 2 minus absolute value of x, and I have that graphed here. When is it increasing and when is it decreasing? Remember, this can be tricky. Increasing means when does the graph have a positive slope? Decreasing means when does the graph have a negative slope? All right, now I got my selection tool. So now we see it has a positive slope from negative infinity up to 0, and it slopes negative from 0 to infinity. When I talk about here being 0, remember I'm referring to that x value. So when we include our answer, we're only going to talk about the x values. It is increasing from negative infinity to 0. And again, we'll use the soft parenthesis because it's neither increasing nor decreasing at that point at the top. And then, of course, it's decreasing from 0 to infinity. Now, you can use this table of values over here. I've filled in a couple of them. But for the most part, you just want to look at the slopes. When was it a positive increasing or a positive slope and to be increasing, or a negative slope to be decreasing? A little bit to think about. Can there be a function that only increases or only decreases? See if you can think of any. Or try it. We want to graph x squared minus 4x. So here we have our parabola. We want to know when is the function increasing and decreasing. Remember, increasing means a positive slope, but we look at the x value. So the x value here, where it turns around from decreasing to increasing, is 2. So we would say it is increasing from 2 to infinity, but it's decreasing in the beginning from negative infinity to 2. Take a look at our second graph here. On 4b, our linear equation, negative 2x minus 3, it is decreasing all of the time. So we would say it's increasing is never happening, and it's decreasing from negative infinity to infinity. That should get you through examples 1, 2, 3, and 4 from topic 1. Be sure to try the homework now.